screens. I see Aya from the UAE, Javed from Dubai, UAE again, from Germany, India, Algeria. There's a diversity of attendees today. I'm very excited to see you all. Okay, I think with this, we have waited for 2 minutes for the majority of the people to join, and I will use the time to kick off the session. Since we have a long session today, we have plenty of experts on the call today, and we'll be very, very happy to share the experience of these speakers with you and also get your questions as we go. So I'll start the session then formally by welcoming you to this webinar that is called Optimizing Energy Output and How Cleaning Robots, Modules, and Trackers Integrate to Maximize the PV Plant Generation and Lifetime. This webinar is sponsored by Sunpure Technology. I think most of you know Sunpure, which is a high-tech, innovative company specialized in R&D, manufacturing, sales, and service of renewable energy intelligent robots for different applications. This webinar is also in participation of industry leaders in the solar industry, as you can see on my screen. We have speakers from Sunpure, CAA, JA Solar, Energize OM, Game Change Solar, and Huadong Engineering Corporation Limited. I'll introduce myself. My name is Munif Barakat. I am from SolarAbic, which is the most visited renewable energy platform dedicated for the MEA region. And we'll be running the session today live on Zoom, in addition to live broadcast on multiple social media platforms, including LinkedIn, Facebook, and Instagram. Just in case you are with us on Zoom, then definitely you will get all the communications from us and through the chat. But if you would like to have access, we have questions if you are watching us on the social media, then please add that in the comments and actually use the comments now, please, to introduce yourself, to tell us from what country you joined us in order for us to also understand our audience better. If you are on Zoom, then this is specifically for you. Many of you used the chat box in order to introduce yourself, and I'm very happy to see you joining us from multiple countries today. But if you have a question to the panelists, our guests today, please don't send that question in the chat section, but send it in the Q&A section. So you will find another button in there near to the chat button on Zoom. And in the Q&A section, you may post your question, and that will be directly visible for us. I'll get notified, and I will prioritize your question in order to get that answered in today's session. I expect that we'll be going for approximately 1 hour and 15 minutes today, probably up to 1 hour and 30 minutes, depending on the quantity and quality of questions that we will receive from you today. Now, the title might be a little bit broad. That's why I wish to first of all give you the context. Why do we run this session today, which is a very unique topic, because we'll be talking about multiple elements, how multiple factors contribute to the success of the power plant, especially that we have seen that the PV industry has grown a big time over the last few years, and we have reached multiple hundreds of gigawatts being installed around the world. And the recent studies showed that there are still this kind of a lot of problems that cause big losses. For example, the soiling alone can reduce the generation efficiency between 4 to 15%. And this costs the industry billions of dollars annually. So that's billions of dollars of missed opportunities to generate electricity in order to maximize the profit for the power plants. And projects at, let's say, gigawatt scale, or actually any utility scale project that used to be 10 years ago, probably managed by manual cleaning or kind of isolated custom designs for cleaning, we don't find that solution effective anymore today. And there are very, let's say, advanced solutions that will help you to maximize the profit from your PV plant. That's why this webinar, sponsored by Sunpure Technology, brings together the leading experts across the PV value chain cleaning robotics, module manufacturers, tracker suppliers, EPC, IPPs to discuss how to integrate and how to improve the design and collaboration to unlock higher energy yields and reduce O&M costs and extend the lifetime of the PV plant. This session also features the launch of pioneering white paper by Sunpure that speaks about the role of intelligent robotic cleaning and cross-system compatibility, providing the workers in this industry with the first look, practical solution, and industry guidelines. This session and the white paper that will be launched in it is designed for EPCs, developers, IPPs, utilities, academics, and policymakers from across the Middle East and Africa specifically, but also it's very much relevant globally to deliver real-world insights, technical deep dives, and future outlooks on how cleaning robots, modules, trackers can integrate together to deliver the best performance for the PV plant. As much as I'm excited about this topic and I want to talk more about it, I guess it's better if you hear it from our experts. And I would like to welcome all of our experts now, introduce them pretty quick, and then each one of them, as the time comes, will introduce themselves and their organizations as well. So for us to better also plan the agenda for today, we will start with 2 keynote speeches. The first keynote speech will be delivered by Dr. David Zhang, who is the CTO at Sunpure Technology, with a session of 15 minutes, and then a keynote speech by Jörg Althaus, who is the Director of Engineering Services and QA Services at CEA, and also will have a presentation for 10 to 15 minutes. And then after that, we will move to the panel discussion, which includes Mr. Alex Sun, who is the Senior Global Solutions Engineer at Sunpure Technology, Asil Saadi, who is the Technical Services Manager at GA Solar, Ahmed Abdurrahman Zairi, the General Manager of Energize OM, Kushkar Gupta, who is the VP of Engineering at Game Change Solar, and Min Tan, who is the Deputy General Manager at Huadong Engineering Corporation Limited. As you can see, we have a very diverse panel today, and I'm very happy to have all of these experts on board. So without any further delays, I'd like to take the opportunity to introduce Dr. David Zhang, or ask him to introduce himself, please, and start sharing, please, your screen. Welcome, Dr. David.
Okay.
A big event today with your presence and the launch of the white paper. We're very happy to have you on board, Dr. David.
Thank you very much. Is my screen visible?
Yes, and it is on full screen. Everything is perfect.
Okay, sure. Okay, so now I can start. Okay.
Sure.
Yeah. Good afternoon and good morning, good evening, everybody. So this is David Zhang from Sunpure. First, I think I would like to say thank you to the organizer and also giving us the opportunity to present our white paper. Okay. So before I started presenting, I think I just like to give a little bit of background about this white paper. Last year, Sunpure published the first white paper globally. So the title of the white paper is the ARCS, the applications and the challenge and solutions. So after we published that white paper, we received a lot of questions, queries, and comments regarding to the white paper and regarding to this industry. Because ARCS has been widely used in Middle East and India, but in other regions, it just started. And even in Middle East, this technology is still not very mature and a lot of challenge is there. And the particular question is how the ARCS, which is the automated robotic cleaning system, integrate with PV modules and trackers. So it's just to accommodate those wide questions. We have started the preparation of our second white paper, so which is named as the application of the RCS and how the collaboration across the modules, the trackers, and the cleaning robots start. Okay, so after the around 5 years of the hard work, so finally today we are going to publish our second white paper. And I'd also like to take this opportunity to thank our partners. So all of these partners has a lot of contribution on the contents of our white paper. So it includes TUV, of course, Sunpure, and JA Solar, Jinko, Longi, Astroenergy, Arctech, Nextracker, and Game Change Solar. So it's just with your contribution and efforts, I think this white paper is published on time and with good quality. And everybody is welcome to download our new white paper through the link later on we'll share in the screen. Okay. So starting from this presentation, why we have this 12-party collaboration is because now all the mainstream robots, we call it real cleaning robot. So this robot is not working independently. This robot is working on top of the modules and also on top of the trackers. So the performance of all these three parties have a lot of impact on each other. Mainly, the factors are the operational stability, the cleaning performance of the robots, and also the possibility of the robots. So the performance of all these three parties have great impact on the overall performance of the plants. So that's why we initiated this cooperation, among all the three players. So first, I just like to summarize on the challenge we have seen over the past 5 to 6 years. The challenge is across all these three players. Okay, first on the module side, if I summarize the challenge, it's mainly the two points. One is the strength of the modules. The second is the degradation of the modules. So the strength, I think, is easy to understand because these years, to control the cost and to improve the efficiency, we have seen the larger module size to be implemented and also even the thinner module frame to be implemented, so that the deflection of the module when the robot is operating is increased. So it reduced the mechanical load capacity of the module over the robots. And the second major point is the coating of the module is going to be weared, after continuous operation of the robot. It can happen after a few months, after a few years, or even longer. So it depends on the quality. Of course, it depends on the quality of the coating. Also depends on the design of the robots. So this is on the module side. On the tracker side, it's mainly the structural compatibility, because each tracker has its own structure design. The robot has to be compatible with the structure design of the trackers. These days, we have seen the challenge of the trackers is also to reduce the cost. We have seen shorter pulling length, even also the thinner pulling thickness. And also, we have seen different structure types like the dual row or multi-row linked drive rows, which will impact on the operation of the robots. And some protrusion like the antennas, like the drive motors, which will likely to have the collision between the robot and the trackers. And the most important is the installation division, especially the angle division, the height division, and also the vertical and the horizontal offset. So this is all on the tracker side. On the system side, the robot and the tracker are not independent, and these two systems always interact with each other. So the main challenge is actually on the communication. With the plant size increased, from megawatt to gigawatt. For each site, we have seen like thousands of robots and tens of thousands of tracker rows. So there's always likely to have for example, the frequency overlap, between the trackers and the robots, and also this lack of unified data of the communication protocols. So this is about the communication. Second is the protection strategy against the extreme weather condition. For example, the tracker will get installed if there's high wind or high snow, or if there is communication loss. And the robot is also going to stall during the high wind speed, or if there's any loss, or if there's any danger that it can anticipate. So how to make the protection strategy to be compatible with each other? So this is another challenge. Okay, so this is the challenge part. Of course, for the last few years, on all the parties, we have spent a lot of continuous efforts mitigate this challenge. So this will be the second part of the white paper. So first we'll talk about from the robot side how to minimize this challenge or how to overcome this challenge. So mainly when it is in terms with the module, so we're talking about the lighter robot body to reduce the module deflection, and the customizer binder to reduce the deflection of the module during the operation of the robot, and the brush material design to have the less damage of the module glass. And of course, the independent motor-driven roller brush with adjustable speed will also contribute to reduce the risk of the robot operation on the module degradation. So and then on the tracker side, so we normally the robot now have the twist robot body design, and the flexible bridge design, and independent docking station design. So this is on the structure side for the compatibility, how to improve the compatibility. And then on the communication side, now all the major robotic vendors use the LoRaWAN mesh networking for the communication, which will improve the communication speed and reduce the signal loss. And of course, the integrated coordination with tracker and weather data is also a must to have the seamless integration of the robotic system into the PV plant. So then from the module side, just now I have mentioned there are two major factors. One is the deflection. The second is the module degradation. To reduce the deflection of the module on during the robot operation, a lot of module suppliers is working on, even they have the reduced thickness, but they increase the stiffness and strength of especially the glass of the module and the frame of the module. And also they are developing the anti-wear and anti-aging coating to improve or increase the life of the coating. So this is on the module side. And on the tracker side, there's also a lot of improvement. Like now all the trackers have the automatically adjustment to the cleaning angle at night. And in the trackers installation manual, they control the offset, horizontal offset, and also the angle difference. So this will help the robot to pass between different adjacent trackers. And some other points, like they will reserve holes for the robot, to install our engineering structures so that the overall cost can be reduced. And they optimize the antenna positions to avoid the interference. And also normally for during all the design for all the sites, the calculation of the load, they have considered the weight of the robot. Of course, sometimes this is not the governing load case, but it's a must to consider. And the most important is optimization of the communication by improving the data transfer speed and reducing the signal loss. Because the operation, whether the robot can be started or it has to stop, it all depends on the tracker angle data. So if this communication can be improved, then the performance of the robot and availability of the robot can also be increased. So this is a major part of our white paper. So second, I just want to spend about 5 minutes to give very short introduction about Sunpure. Okay, so we are the leading robotic cleaning company in this renewable energy industry. We started actually in 2019, and we are the technology orientated. So each year, if you see the roadmap of our product, each year we have our new products launched. So now we already have 4 different types of products, including the real robot, the trackless robot, the module installation robot, and also the AGV robot. So this will cover different scenarios and for different purpose. And so this is some summary of our company. And since we started in 2019, we have already deployed over 75,000 of robots globally. It's mainly in Middle East, India, China, and Latin America. And we have over 300 patents and 60 plus of people who have PhD and master degrees. And some important highlight I want to mention is we have initiated the first industry standard, the first industry's white paper, and our lab is the first lab which is qualified by TUV, and we also have the only wind and sun lab in this industry. So this is a comprehensive R&D system we have to driving the upgrade of the industry and to maintain the good quality and reliability of our structure of our robotic cleaning system. And we are well recognized by the leading industry partners, including some IPPs, EPCs, module suppliers, tracker suppliers, and also the third parties. So that's all for my short presentation. This is the link for the download of our white paper. If anybody interested in reading, feel free to download it. It does include a lot of effort from us and from our partners. So hopefully this white paper can help you to answer your questions and also to help to improve the efficiency of the power plant. Okay,
Great.
So that's all about my presentation. Thank you very much.
Thank you very much, Dr. David, for sharing the expertise today. I'm very happy that we're hosting one of the technology leaders around the world in this domain. And the white paper, I've read this myself, learned a lot from it, and I can only suggest to everyone to pick up your phone, scan the QR code, and we'll be sending the link soon as well in the messages in order to download it. And if you have bad quality on social media for the image or you cannot reach it, just write us in a comment on social media, write us your email address, and then we can email that to you. So however you are comfortable, let us know, but definitely it's a must read for everyone. Thank you, Dr. David, for sharing.
All right, thank you.
Thank you. Okay, now we'll move to the second part of today's session. We're very happy to host again Mr. Jörg Althaus, who is the Director of Engineering Services and Quality Assurance Services at CEA. We've hosted him in multiple hats. Now this is the second company where we have Jörg with us representing the highest quality standards in the industry, and he will tell us more about it. You're welcome, Jörg.
Thank you, Monif. Let me just see if I can share the screen.
Yes, sure.
All right. Thank you for having me today. Short notice edition, and I hope I can add some interesting parts. I'm not going to talk about robots, so anybody that's disappointed about that, I'm sorry. I'm going to talk about modules that people know me for, but also about how modules integrate with trackers and what to look at when procuring one or the other. And with no further ado, I'll just start. And in my case, I'll start with a quick company snapshot, keep it short. Clean Energy Associates is a company that acts as a third party in solar and energy storage. Uniquely, it's now part of the Intertek group, which is a global third party with more than 44,000 employees around the globe. CA itself is active in has presence in 15 countries, active in more than 85. And we work in 5 business units, basically helping customers around the world securing quality of their solar assets or storage assets, from contracts drafting all the way through operation, maintenance, and even dismantling these days, with recycling added to the portfolio. But my job is the quality assurance and also the engineering service, which covers quality from factory to field. And with that, I'll start into my quick run through the years. We just heard it also from the previous presentation that PV modules have gone through an evolution. Crystalline PV modules, which dominates the market these days, have recently, since 2024, increased massively in size. At the same time, we went from glass polymeric backsheet to glass, and that glass is now partially tempered, not like the previous 3.2 millimeter glass fully tempered. So this means it's only 1.8 to 2 millimeters thick. And also we've seen that the frame profiles have been mostly reduced a little bit. There are exceptions. And at the same time, that meant that the racking or tracker manufacturers had to respond to that and increase the lengths of the rails, adjust the hole pitch, reinforce the gaskets between the rail and module frame, also increase the height of the whole tracker, and of course go through static calculations and do further wind tunnel testing and all of what goes along with mechanical structural design. And as a result, you see here a schematic I borrowed from NREL. We also see different load on the modules under wind. And with that also came some problems maybe. But first, let's see how does it usually work when somebody is doing a project. Usually, the PV module manufacturer has their module designed and qualified according to international standards like IEC 61215, IEC 61730, making sure environmental stress is fulfilled and also safety is there. Then they have installation manuals with all the tested mounting positions and different loads they approve for their warranty conditions. And also in lab testing, mostly these days in their own labs, they do excessive testing of those modules, also repeatedly, according to their standard, which prescribes a uniform load. And there is nowadays a static mechanical load test as well as a dynamic mechanical load test. But the testing is applied by a machine that typically works with pneumatic suction caps or with sandbags, what have you, in a uniform manner. And then the module manufacturer provides usually a compatibility letter for your project, saying if you use this racking or this tracker for that site under these wind load conditions, my module is good with that mounting situation. At the same time, the tracker manufacturer usually designs their product against also international standards, does excessive wind tunnel testing, and also non-uniform load distribution, because when the tracker is in a high position, usually the wind pressure and suction leads to non-uniform load distribution. Likewise, the tracker manufacturer usually provides a compatibility letter for a particular module with its weight and its mounting position for the tracker, and but does not give a warranty for any damage on the modules because it's not their product. Now the EPC takes all this and designs the wind or executes basically on the designed wind loads, and is responsible for mounting and assembly, checks conformity of the system against what was warranted, and then holds the warranty for the workmanship for the first few years. The owner usually hires the EPC and possibly a technical consultant and of course an O&M company to maintain the project, and is responsible to check that the project's requirements are met and also basically prescribe those. In case of failure, however, usually that's the first person or entity to go to, and would then, if they wanted to claim against any of the previous mentioned parties, provide a claim with a root cause analysis. Now, if all these products are tested and qualified, why do we see things like this happen in the field, where obviously something wasn't either executed, designed, or maintained the way it should have been? And we see currently, unfortunately, as a third party, an increase of projects where we see predominantly back glass breakage, but as you can see on these images, also more severe. Now, glass breakage has multiple root causes. First of all, we need to acknowledge that glass is a material that is not the same every glass sheet that is coming off the factory. That's why in construction world, whenever somebody makes glass facades or something, glass gets tested in high volume sample rates and well beyond test to failure, high safety margins to actually have qualification for such. However, in PV, we usually have the mechanical load testing on the modules, which is single tests for certification. Then, of course, the supplier does regular tests with the glass being 3.2 millimeter fully tempered and thick frames. In the past, there was always sufficient safety margins. Nowadays, with the cost decrease, we seem to have come at some points at a minimization of those safety margins, and sometimes the external stresses are just too much. But there are multiple things that can cause the glass breaking. It could be that the glass itself has issues with the drilling holes in the junction box area, not having some damages with pure edge grinding, basically having around the edges of the glass some damages that could lead to cracks. Framing of the module could be built in tension. We've seen that sometimes frames were too tight or touching the glass with the metal on the edges, not sufficient silicon inside. But there could also be impurities inside the glass itself or inadequate heat strengthening. And then, of course, from the tracker side, there could be stress built in because the module is mounted too tight on the rack. Then, of course, we have strong weather events like hail, storm, or even extreme temperature gradients. Installation errors where clamps are too tight, where just the installation method is not followed according to manual, or the racking system wasn't approved by one of the other parties. And finally, maintenance. We heard about robots. Hopefully, the more robots, and I heard there is a lot of AI going into that now. That's not the issue. But if you have, of course, manual interaction or vehicles driving in the plant, there is risk that can be maintained, but there is certainly a risk of personal activity on site. Now, I want to go through you with two case studies that I brought, and both cases where we as a third party were called on site, helping the owner to identify what happened, why did it happen, and what can be done to formulate a claim or even mitigate this happening again in the future. First case here, a solar developer had glass breakage across multiple PV sites. We did an on-site inspection. We also did structural assessment and laboratory testing to basically represent what was seen in the field, basically taking exactly what we saw on site and replicating the situation in lab, rather than having just one single module tested on a steady laboratory test bench. We try to replicate the exact mounting parts, including the purlins, and put two modules in parallel to allow bending and so on. 2,600 modules were found with breakage. Some failures had impact. You see here on the bottom, that's what can happen with grass cutting or stones flying, then a very unique shape of cracks. That of course can happen, but it wasn't the magnitude or the majority of the modules. And some modules failed the laboratory testing, and we saw modules having cell cracks, but also glass cracks. What we saw in the laboratory testing is that the modules were twisting because the substructure allowed for that. And this is something that the IEC test doesn't look at the moment. It used to. But we also found on the field that many clamps were too tight, exceeding the torque prescribed by the installation manual. I'll go into the next case, but what you hear from what I'm saying is there was at least 3 different reasons for breakage. So it's not always an easy task to identify what really went wrong and clearly make out who made a mistake. Sometimes it's just multiple things coming together and then finally leading to a failure. The second case here, quite similar, 100 megawatt PV system. Structural forensic was done, basically doing finite element simulation of the system. Again, doing laboratory mechanical load testing, dynamic and static. And we also did glass analysis regarding the surface stress. What we found, you can see on the picture, is one thing I mentioned before: the frame was tight and the glass was actually facing pre-stress, even without any load on the modules, which you can see here in the simulation that already leads to some stress inside the glass. Then replicating the installation method in the lab and having 2 modules tested, you can see on the bottom picture that the purlin bent, and basically under dynamic testing made some of the modules slip out of the clamps and not actually sustaining the maximum load that they were passed for. This is again something, the module was totally fine under mechanical load testing as per standard, but in the combination with the racking, it had issues. It had no issues in the static mechanical load, but in the dynamic mechanical load. And so the summary of this basically is that IEC standard currently doesn't look at twisting or this non-uniform load distribution that racking manufacturers do in their design, and that quite likely is one of the reasons why we see an increase in failure. Now, what do we do about it? We suggest that we do 3 things. One thing is make sure that the products that you purchase, including the modules and the rackings, are compliant to the criteria that you have discussed with the supplier, and hire a third party to make sure that's happening in the factory. Quality oversight is something that is really important to make sure everyday module going out to your project is according to the agreed requirements. On top of that, review what the suppliers do themselves as incoming goods quality control regarding the glass, just to avoid that there is an issue with the glass, limiting the issues with the glass, the issues with the modules, and then on the racking already basically excludes that there is a product issue. Then, as I said, the module maker typically tests the module, the racking manufacturer typically tests the racking, but the combination of both is sometimes tested, not always in every combination. Therefore, for large systems, we recommend that you replicate the actual system mechanical installation as you will do on site in laboratory testing. And we also suggest to do side-by-side testing of 2 modules to be more accurate in terms of what is going to be built in the field. The glass tension is something we are basically talking about 60, 65 plus minus 10 megapascal surface tension compared to 140 in tempered glass. This is giving quite a range, plus minus 10 or even plus minus 15. So make sure there's uniformity across the different products, and then we can basically also say the glass may not be the issue. Site inspections validate that everything is done according to the specifications. The installation methods are followed. All the spacers, bumpers, what have you, are actually installed. Torque values are kept. And check in case you're seeing first damages. When did they occur? Do they have a dependency on strong weather events? Yes or no? Is it happening after cleaning? Yes or no? Document any non-conformities with photo imagery, and then hopefully you have not hopefully, you are in the best position to make sure when something goes wrong, you know why. And with that, I thank you for your attention. I hope I was not too quick with my presentation. Just a side note, tomorrow there's a webinar by my colleague also for this region on quality assurance on PV modules. Muniv, if there's any questions, I'm happy to stay.
Thank you. Thank you. Appreciate it, Jörg. Really enjoyed going through this presentation. In the end of the day, I got a quick question, like how would this, let's say, then I think it's becoming more complicated to determine the warranty, let's say, responsibility in this case. As you've seen, we've seen on your presentation, multiple reasons, 3 different reasons for the glass breakage, and each one of them would lead contractually to a different scenario. So how do you see, like, as the best way, let's say, for the developer or IPP asset owner to protect themselves?
Well, I mean, in a situation where you have thousands of modules breaking, then of course it's important for any involved party to basically also save their neck. So nobody's going to say, "Yeah, it was me." First of all, what we find is the first reaction of the module supplier is maintenance, cleaning, or grass cutting is the issue. So the first important message is, make sure you analyze the cracks by an expert, that you can say this is external impact, yes or no. Then again, check whether the system was built to plan and the plan was approved by every party. Then, as I said, do the testing to prepare a claim. If the module doesn't withstand under this prescribed load in the correct and warranted installation method, then read the fine print of your warranty claims, but it seems like you would be in a warranty situation. But likewise, if there was a strong weather event, you likely go to insurance. So you're right to say that there are multiple things that could lead to a different party to be the receiver of a claim, but our suggestion is to come prepared. Muniv, I don't hear you. I think you're on mute.
Oh, sorry. I wanted to thank you, Jörg, for your contribution. I enjoyed listening to your session. And if there are any questions that will come to you, then I'll forward that by email. Okay?
Thank you so much, Muniv. Have a good session.
Thank you, Jörg. Thank you. Then, meanwhile, I think it will be also beneficial for us to know from what country you joined us today. So there's a quick poll that is on your Zoom screen, if you are watching us on Zoom, to let us know from what country have you joined us today. I think it makes a lot of sense to get that and more insights about this in order to improve the inputs or the discussion points that we'll have today. If you're on social media, please write that in the comments under the video. Just tell us from what country you joined us today. As you can see, I think most of the people with us, approximately 36%, are from the GCC region, with a good distribution from across the MEA region and other countries as well. Very happy to have you on board. And the second and last question, I'd like to get to know, please, your industry, to tell us if you work for a developer, an EPC, service provider, or an O&M company, investor, if you work in the public sector, academia, or as a consultant, then please let us know. I think most of the options in here represent, or the options here represent most of the cases that we have. And I see that we have quite a variety in here from the answers. Let me put that quickly on the screen. Obviously, we didn't get everyone to vote yet, but we had a good feeling that there's approximately 15% developers, 15% EPC, 25% O&M and service providers, in addition to other industry players like consultants and academia. Everyone is welcome, and we are very happy to have you all on board. And I would like now to take the opportunity to invite the panelists to join the next section. We will be having a panel discussion as per the program today. So I'd like to invite Alex, Ahmed, Asil, Min, Tan, and Kushagr to please join me in this part. With a quick introduction, please, from each one of you, if you just tell us a couple of words about your organization and your role before we dive deep into the questions. And the first one that I'll be targeting is Ahmed, to help us to lay the ground for the discussion. But first, let's start with the intros. I'd invite Alex, Ahmed, Asil, Min, and then Kushagr to introduce yourselves, please.
Thank you
Alex?
very much, Munif.
Ahmed.
Thank you very much, Munif, and for the good moderation above all. Appreciate
Thank you.
the presence to be here in this excellent webinar. My name is Ahmed Al-Zahairi. I am the General Manager of Energize On-Them, the first in-house On-Them company incepted by Masdar Specialized Technical Services, the On-Them arm of Masdar, the clean energy giant from Abu Dhabi, and EDF Power Solution, the French renowned state utility company. Energize, when it was incepted, it was aiming to take over the O&M period of their respective assets, especially the assets that is joint venture by both shareholders, where they are having stake and interest, for the aim of achieving three main goals. The first goal is to preserve the asset value. The second goal is to realize the operational excellence endeavor, aiming for the efficiency, aims also as well for the digitalization, and most importantly, the cementing of the HSE culture during the on-them period, which is a very critical matter. The third and most important objective is to realize the environmental and social objectives of this investment. Energize was still the player since 2021 by both shareholder, and we are hoping to expand in the region here for annex more assets to be operated under Energize. Thank you, Munir.
Thank you, Ahmed. I appreciate this introduction. Alex?
Okay. Thank you, Monif, and good afternoon, everyone. My name is Alex. I'm a solution engineer from Sunpure. My primary work is to support Sunpure's projects in Middle East, Latin America, and India. And today it's a great honor to be invited here with all the industry experts. I believe we will have a very pleasant discussion about module, tracker, and robot system. Thank you.
Thank you. I appreciate this, Alex. Then Asil, please.
Hello, everyone. My name is Asil Astadi, and I'm Technical Manager of JA Solar Middle East and Central Asia. Thank you for joining this webinar today, and I'm looking forward to sharing some insights about JA Solar compatibility with the trackers and cleaning robots. And I'm looking forward also to hearing some perspective from panelists as well. Thank you.
Thank you, Asil. I'll move then next, as I see on the camera, Kushagr, please.
Hi, good day to all. I'm Kushag. I'm heading the engineering for India, Middle East, South Africa, Australia. So basically in the non-US jobs. Good to have all of you, and looking forward to a good conversation. Yeah.
Thank you, Kushag. I appreciate that. And then we move to Mintan, please.
Yeah, good afternoon, everyone. This is Amy from our China Huadong site. So, as EPC perspective, we integrate the engineering for the cleaning robot, the pure motors, as well as the cleaning robot, not only for the engineering phase, but also for the construction and commissioning, and also the operation phase. So we might have some for the service life discussion regarding the integration of all the components. Thank you.
Perfect. Thank you, Emma, for the introduction. Okay, so I will, with this esteemed panel, I'm very happy that we will be focusing on two major points. Obviously, there's a lot to talk about, but I think if we have one or two focus points to try to attack in this panel, try to address in details and to clarify to our audience, then we'll be achieving great success. And meanwhile, I would like to encourage the audience to write their questions in the Q&A section as soon as you get the question in your mind. Don't delay to the end, because maybe I can incept that in our discussion, or we focus on that and you can influence this discussion with us today. So please use that tool so we can make the best use out of it. So I will first start with Ahmed to lead the discussion, and then with Amy to lead the second one. The first one with Ahmed, I'd like to ask you, like, we'll talk a lot about soiling and the importance of that. And for you in Energize O&M, you represent the interest of the owners of the assets in order to optimize and the performance of the plant to get use of or generate every possible kilowatt hour out of that. So what are the typical soiling targets and soiling guarantees in a big utility scale power plant?
Thank you, Munif. Well, the soiling targets, of course, differs between project to another. It depends also what budget you are using for the module cleaning nowadays. Of course, thanks to Sunpure and the major and the leader on O&M on the robots, we can have the plant cleaned once in a day. While in the past, some of the assets that we are having, the plant was semi-automatic robots where we can clean the plant maybe once in a week, and especially we are talking about a gigawatt scale power plant. So that's why the target is adjusted from the engineering stage based on what is our philosophy for the soil management that is to the technology of the robot that is used. But widely speaking, when we are talking about the soil management, we must approach an integrated strategy rather than a one-off activity. Okay, and for that, we typically achieve the soiling target through a combination of data-driven planning and technology deployment and operational discipline above all. And this is how you can bring the added value to your client, as you rightfully mentioned, by increasing the generation, by reducing the soiling loss reasonably, while we are also holding your grounds to maintain a wise OPEX for the cleaning itself. So, for example, for the main verticals that we are working for the soiling targets, we are firstly focusing on the soil monitoring and the benchmarking. So normally during the design of the plan, we are maintaining a soiling complete air weather station, including the soiling sensors for each 30 to 50 megawatt. It depends on the region and the area and how the soiling is there. And also reference strings, across the plant to quantify the soiling losses in real time. This is very important. And then we correlate the data in any multivariate model. We have our dust deposition model and the SCADA analytics. Nowadays, with the evolution of the AI, you can have analytics that does this job for you, and also allowing site-specific soiling threshold. Usually, it is between 0.5% to 3%. It depends again what is the technology used in order to have a level between the energy generated and the OPEX invested to offset the soiling losses. Second point of our focus is to the cleaning strategy itself and the optimization. as we need to focus again between the energy and the OpEx. So here we are seeing what are the cleaning schedule and how it can be optimized for based on the forecast that we can having from the analytics or the multivariate model that I just mentioned. So there's some peak months of generation where we can say, okay, there is a business case where we can push for more cleaning cycles to achieve less soiling losses compared to other days of the year where we are, let's say, it is not making sense to push for more cycling where the radiance is low. Okay, so that is one of the examples how we can optimize the cleaning schedule, and we having a very reasonable cleaning cost throughout the year. And the same we look into how we can govern and the KPI for the cleaning itself. So we always tie our soiling targets to the plant availability and the generation and the performance ratio in order to make a sense or reasoning how the soiling targets are set for and what are the benefits that we got. On the other hand, also we are checking on site physically in a certain periodicity about how the cleaning coverage is, the status of the robots and the logbook, all these normal on them matters that really help
procedures
you to balance,
that we do.
Exactly.
Okay, perfect. Thank you, Ahmed, for this. You lay for us the ground, and I think I'll move that to Alex. I think from what I understand from Ahmed's input that the requirements are strict and the IPPs expect a lot, let's say, when it comes to module cleaning, because the soiling limits that have just been mentioned are very low, and daily cleaning, as Ahmed mentioned, are also required for these plants. And at the same time, we have seen in Jörg's presentation that the equipment is evolving a lot, and there are issues with the reliability of equipment. Like I'm talking about modules, structure, and tracker. So I want to ask you, since the robot comes in the end on top of everything, so it has to everything has to be ready and smooth for the robot to work well, and it's very easy to blame the robot, let's say, if something goes wrong or so, even if it's not a robot problem. So I want to ask you, how did the design of Sunpure's robot evolve to accommodate all of these changes in the products, like modules and trackers, and with the high expectations from the investors?
Okay, thank you, Monif. Well, I have to say you are 100% correct. All the challenges are on our side. But I have to say this is a systematic and a continuous process of changing. And generally speaking, to accommodate the changes of module and tracker, the robot is always becoming lighter, stronger, and smarter. And first of all, it's lighter. As Dr. David mentioned in his presentation, over the past few years, the mainstream PV modules has becoming larger dimensions and thinner frames, which reduced its mechanical load-bearing capacity. And if the robot is too heavy, there will be a severe deformation at the edge of modules. And in the meantime, the purling of trackers is also becoming shorter and thinner, which also aggravates this kind of deformation. So we must continuously reduce the weight of robots. For example, in the scenario of 1P tracker, our previous generation of robots was more than 60 kilograms, and our current generation is around 50 kilograms. And our next generation, by the way, is still under development. We are targeting on 40 kilograms. And second point is about stronger. This point is mainly about the cleaning efficiency. We always have to maximize the removal of soiling and minimize the wear and tear on the surface of module glass. But these two purposes are often contradictory. It's very simple. If we clean the module harder, more soiling will be removed, but also more pressure will be put on the module glass. So we have to do a lot of research on the brush itself, including the material, the density, and the overlapping between hair and the module glass, and the rotating speed. I think this kind of research will keep going always. And last point is smarter. This point is clearly indicated in the white paper in chapter 2. The stable operation of robot system is influenced by multiple factors, such like the installation accuracy of piles and structures, the on-go offset between adjacent trackers, the wireless communication between different equipment, and the data transmission between different protocols. All these factors, they are driving the robot to become more and more intelligent. For example, the robot must be sensitive to detect abnormal signal coming from different systems, like the wind speeds and the raining from weather station, the tracker on-go from tracker system, the alarms from PV SCADA, and the abnormal current or posture from the robot sensors. And then after receive this enough information, the robot must be intelligent to decide what to do next step, to carry on or stop, to slow down or speed up. And at the last, the robot must be flexible enough to perform these different actions against different kinds of situations.
Perfect. Thank you, Alex. So like that's challenging job, yeah? Like you want to make it lighter, more reliable, more effective, and the customer expected to be also cheaper. And
Cheaper. Always cheaper.
It's smarter, cheaper, more reliable, lighter. So like that's a lot of things on your shoulders. I'm sure that's why you need a company with proper R&D like what you have at Sunpure in order to have such a combination. I'll get back to you in this regards, Alex. But first, I'll hear now from the module, then tracker, and then EPC perspective, how to put this together. And then before we dive into the next topic. So I'll move to you, Asil, first. There's a lot of focus definitely on soiling, but also, as you have seen from York's presentation on reliability, especially that everyone is under cost pressure in order to deliver, let's say, what people got used to or investors got used to, cheaper modules, cheaper structure, especially modules at the historically low, let's say, price point over the last year. The raw material for tracker and structure are also like with being at the lowest prices also from a long time for commodities. So how do you, let's say, deal with this high expectation from the price level and cost level, but at the same time I see that you innovate in the direction of having anti-soiling modules or, let's say, improved efficiency in order to increase the value out of the plant. So my specific question to you, tell us, please, from a module manufacturer perspective, what is your recommendation to deal with soiling and what you do from your side to improve in that aspect, please?
Okay, Munif. Let's break down the question. First of all, I would like to talk about our region because our region is prone to frequent sand and dusty storms, and the dust deposition can act as a barrier between the available surface area of the module and the generated power. So it will cause power loss if it's accumulated on the surfaces of PV modules, but the extent of power loss depends on the density of this dust accumulation. So, as my colleagues from different companies stated that the modules are changing and increasing, and we change the material, moving from M10 to G12 and G12R wafer formats. So, cleaning robot should adapt carefully to these large designs to avoid any frame deformation, glass stresses, or micro cracks. So the robot selected for the use of any project should be first engineered and installed in a way that prevents any undue pressure on the modules or cause any scratches of the modules itself. So ultimately, it's a shared effort between the module supplier, as we are JA Solar, who provide the quality modules, and the cleaning robots such as Sunpure, of course, and the tracker suppliers, in order to maintain the system and ensure that the system as a whole works reliable and stable industry environments. And at JA Solar, we recommend to prioritize using the cleaning robot that have passed JA Solar compatibility tests, in which the robot that passed this test has undergone 10,000 accelerated cleaning cycles, equivalent to 30 years of operation in under simulated local environment. So, which the results have no power degradation higher than 1%, no any additional microcracks generated, no any frame or visible damage happened to the modules after the test. And recommending to use the past to JSR compatibility testing of such kind of cleaning robot that have passed JSR compatibility testing, this is what we prioritize. But even if there is any cleaning robot that have not tested according to JSR compatibility test protocol, they have the clients have to check JSOLR cleaning manuals, in which we provide some key performance indicators for the clients about the brushes used, the brushes, the speed, the roller speed, the climbing angle of the robot that intended to be used, whether it's resident robot or mobile one.
And I have a question. So, do you have a specific recommendation? That's one. I see that question in the Q&A. Any range of weight for the robots to be used, for the cleaning robots to be used on JA modules, or how, or do you manage it project by project?
That's a critical question, because as I stated that earlier, that we have a protocol for cleaning. If the cleaning robot already tested to JSOLR protocol, then they can use it. If the cleaning robot has not been tested for JSOLR cleaning robot, they have to check JSOLR cleaning guidelines, in which we include the brushes, like the diameter and the brush's specification, the hardness of the brusher, the roller brush speed, and the climbing angle, high overrun. So every robot needs to be used, have to be we have to check the data sheet and to make sure that it's under JSOLR key performance indicators that already published in our cleaning manual. So it's case by case.
Case by case, especially for the big projects, I think. And also from project to project, a lot of things change, yeah? Like you upgrade the module from your side, the robot upgrades as well. And I think it's difficult to say a specific number, right? I get that right, I see?
Yeah.
Okay.
There is no such way. There is key performance indicators for brush hardness, roller speed, climbing angle, overruns. I highly recommend you to go over cleaning manual of JA Solar once you use JA Solar modules to find these specifications.
Perfect. Thank you, Asi. Thank you. Now we come to another component, which is the solar tracker by one of the leaders in manufacturing. So trackers game change, and Kushal, we're happy to have you on board. I've delayed your part because it's the part that actually carries everything. Yeah? Carries the modules and the robots, and we've seen also there's some developments in the tracker design with time, with the let's say evolving requirement again to reduce costs from one side, since the steel prices have went down. It's to like maybe the lowest in the last 10 years, and then like there are, let's say, high expectations for that, and at the same time the design and the size of module changes and the robot is evolving. So how do you manage this, let's say, evolving change from your side when it comes to the engineering of the tracker?
Yeah, so right now we are actually living in a very interesting time. The challenges are more. We are going for much more capex sensitive projects. As stated, the blame game comes in, to the robotic guys, to the tracker guys. If there's something wrong, but whatever we do, there's a lot of R&D involved in that entire sub chain part of it. So especially for the Saudi projects, we have a lot of site-specific studies, which we orient either from CPP or from RWDI, which ensures that from the lenders and the insurers perspective, you have a dedicated backing either through a EPC or a developer. We also have, additional ramp rate studies, which also helps you to go for those high gust winds in high wind zone events. There are a lot of events which are happening across the Saudi, and since many gigawatt of plants are getting installed, so this is also a critical part of it. In addition to that, from the robotics part of it, we have something called as DCT. That's called a design conformity test. It's basically like a X-rated testing, which is done for a tenure of say 2 or 3 months, right, in which a third party is involved. The entire setup, which is being placed with respect to a specific project, say our tracker having a specific model with a specific module of say JA with Sunpure robot, right? The entire assembly is sent for a DCT, design conformity test, and maybe a third party gets associated like QV. They do this X-rated testing. We have a lot of good procedure, which is based upon the agreements from the developers and the OE engineers. This is a lot of rigorous testing that confirms that for a design life of say 25 or 30 years, the project can withstand with all these three things combined. In addition to that, there were things that, from the modules perspective, as you stated, the modules are becoming bigger, larger, and the frames are also getting smaller. So we do have testing done from the IEC 61215 perspective. In addition to that, from game change front, what we encourage the entire industry is to follow unbalanced loading. Unbalanced loading means if you have a module, the load actually gets more focused towards one area and gets gradually distributed and reduced going towards the end. So it actually mimics a realistic scenario from the actual project sites which are getting installed. This also, mimics how a robotic also behaves. So from the robotic perspective also, you have a little bit of unbalanced load. The battery may not be, centrally loaded and maybe loaded either on the top part of it or on the bottom part of it. So this sort of unbalanced loading also assures the developers that, this sort of symmetric testing is being done. We do a lot of calculations, and in the FE also we've done the entire uh, go through for this entire life. But yeah, this is some exact realistic practical testing which helps the lenders to have much more confidence. And if you bring like a third party also to UV, so that also gives you additional assurance. For the shorter purlins or the longer purlins, you always do that entire testing combined with the purlin assembly for the tracker, so that whatever we are installing at the end at the site is actually getting tested from the DCT perspective. And this is how it helps us. Frames are obviously getting smaller, but the laminate also plays a very important role. The modules are supposed to behave a little bit of flexible because the laminate properties, but we do ensure that it doesn't go beyond the deflection limit that is being specified from the module perspective. Yeah.
Mm-hmm. Thank you, Kushak, for this input. Actually, this leads us very well to ask Amy from EPC perspective. Yeah, we have Amy. If you can hear me, please. We don't see you.
Yes, I can. I can listen.
Okay, thank you. So there's a positive message from Kushak, yeah, about the developments and the conformity and getting certified, let's say by TUV could give some assurance, let's say, for the client, and the product is better. The same also message is from JE as a manufacturer of solar modules about the development of the product, and being also having specific procedures for the to realize the best, let's say, generation out of these modules, as was mentioned by Asil. Before that, Alex from Sunpure spoke about the product getting smarter, lighter, better, and all of that. So if we look to every OEM that is producing the parts, they provide us with a set of, let's say, conformity standards with IEC standards and a lot of quality certifications. Is this enough for you as an EPC? Does it mean that the EPC can take any certified or, for, let's say, approved module, tracker, inverter, robot, put them together, and they will work for sure very well? Or there is a big responsibility on the shoulders of the EPC?
Yeah, thank you, Ms. Mani, for this point. Let me actually, as we know that as an EPC, we request front-end engineering from all the parties, from all the OEMs to understand the actual specific technical requirement between parties. As just mentioned, the design capability test, this to be confirmed with all the OEMs. And the second part is the engineering, expect for the engineering. The second one is the like the communication, data acquisition, and also the software. This interface between all the parties also to be considered. And not only the structure, like we increase the pooling size, or we increase the we decrease the pure motors frame, or we increase the power beams. So as we know that all the technique is more intelligent, but still we need to like the communication software to be more AI or more intelligent with all the OEMs. And as for the you know, the responsibility, that we know that from EPC part we have to guarantee the performance, like the energy performance, and also the PR ratio. So all these critical components, like the power, the pure motors, the trackers, and also cleaning board robot have dominate to the guarantee or from EPC side. So like just mentioned, the soil and loss, which is a very critical section in the simulation, and also during the actual performance, it is very critical for us. So we need the cleaning robot to support us to decrease the soil loss of and increase the performance. So that is all. Thank you.
Thank you for this, Amy. I appreciate this, and I would like to take the same point to you, Alex. Yeah, like from your side, because you also, as the EPC, has the responsibility to integrate all the different parts. As well, the robot comes in the end and has to work with the different parts, let's say, that are in there in the plant. So how do you, what are your recommendations, yeah, to have this collaboration among different industry players to maximize the generation and the lifetime of a PV plant? You're on mute, Alex. We don't hear you.
Okay, thank you, Monif.
Thanks.
Well, I think from the perspective of owner, the plant owner, module, tracker, and robots, together they created an interactive system. So each part of this system has to guarantee its own healthy operation and reduce the adverse impacts on other parts. Because I think this is something like the barrel effect. The final PV generation depends on the weakest link of the system. So each part, we all need to make some compromise to accommodate each other. For example, the module industry like LONGi, GE Solar, they are optimizing their coating technology on the front glass. They are optimizing their design of the frame. And when they are optimizing, they are not only considering the transmittance or wind resistance, they are also considering the aberration resistance, mechanical impact, and extra pressure introduced by robots. Also, the tracker system, they are also making some additional design to be compatible with the robot system. For example, they have to reserve some positions and installation holes in their purlin and torque tube to install our connecting bridges. They have to turn their trackers to the cleaning angle automatically after the daily rotation. They also have to open source their angle information and weather information to the PV SCADA so we can share them. All these changes, if without robots, they don't have to do that. So as I said, we all need to make some compromise. And regarding the robot system, I think I have explained a lot in the first question. We will also make the continuous improvement to guarantee higher cleaning efficiency and lower influence on module and tracker.
Thank you for that, Alex. And if we take this to you, Kushag, please, this collaboration obviously is needed. And I wanted to ask you, how do you typically collaborate with robots manufacturers, especially for projects that have requirements of high wind speeds? I think talking about 12 meters per second or more, robots that have also evolved in their designs. You have also some stowing techniques that could affect the operations of the robots. If you tell us, please, about the typical, let's say, your view about the collaboration with the robot manufacturers, please.
Yeah, so we have collaborated with many of the robotic manufacturers. We have obviously done a lot of projects with Sunpure also. So we have almost a base, I think, of nearly 3.5 gigawatts around the world. And luckily, the most of the projects are working well because we have planned them in the right way. The important things are, as I mentioned, right? One is on the DCDV part of it. So whatever components are being placed needs to be integrated in the right way. The problems that I usually see in the industry is that many of these things get finalized at the later stage. Maybe the robotic OEM gets finalized when the project is about to be commissioned, right? And those entire SOPs are not into place, which are supposed to be from the start, right? So the entire integration doesn't happen, and only at the last stage the robotic OEM comes, getting finalized from the developer, from the O&M perspective, and then they have to agree to certain tolerances which may not be possible for on the realistic side of it, because of either for very aggressive terrain conditions or from other various parts of it. On the collaboration side, we are in constant touch. So as Alex also mentioned, right, the good thing is that the robots are also getting lighter. So 50 kgs of robots is quite less. That helps to capture all this entire capex scenario, wherein the modules are also getting lighter and the tracker is also being squeezed to go for much more optimized numbers. Yeah. Um,
Yeah, perfect. Thank you. Thank you for this, Kushag. And I think this is, let's say, a very important topic to focus on. And this platform is one of these, like when we come to meet together to share thoughts about how can we work better together in order to optimize the performance and the design of the plants and the operations afterwards. So I'm being cautious of time now with having 5 minutes left. I want to pass a couple of important questions that we have received. And I have a question that is received from Mr. Gabi Jrej, and I would like to direct it to Asil, please. And he's asking about the recommendations for the region, especially large-scale utility solar plants in the GCC region, to do water-based cleaning or dry cleaning, or what is, let's say, your recommendation or observation about what is being implemented?
Okay, it depends on the project itself. Like majority of small-scale projects, they use dry cleaning and not robots. But for large scale and utility scale, they use robots with whether it's dry or wet. So it depends on the project. But if the project has like a frequent dust accumulation, they use wet in order to remove the abrasion and to remove the dust particles easier from the projects. But we have to care about the cost, and we have to care about the water used for any project to be sustainable. So obviously it depends on the project. There is no such a standard, and there is no such a recommendation whether to use a dry or a wet one. So it depends on the robot itself. It depends on the environment that we are installing the project on, and it depends on the density of dust accumulated on the project. The combination of these can let you decide which cleaning robot you have to use.
Thank you for this. And then if I move this to Ahmed, please, to comment on the same topic, especially that I have another question asking what is the difference between manual cleaning and robotic cleaning? Like, is there a big difference? I have a question which I think would also be worth mentioning. is the cost of the robot and the energy that will be used, electricity will be used by the robot to operate worth the gained energy because of the frequent cleaning or not? That's something that we received from Kissel Idir and Mr. Muhammad Abu Faraj.
Okay. So let's start by first manual versus robotic cleaning. This is predominantly depend on where the region of your plant. Okay, and in some regions there is, of course, the manpower is working is costing less or maybe cheaper than the robot, but definitely on the longer run, if you are comparing you using a simple economical analysis, net present value, ROI. In most of the regions, you will always see that using a robot is much more beneficial, okay, on your OPEX, number one, and your plant efficiency and reliability and generation, number two, than using a manual cleaners. But again, it depends. This is here the question now that is, of course, it's becoming very obsolete, whether I invest in robots or whether I continue manual cleaning. And definitely most of the IPPs nowadays
Or something in between,
world,
yeah, like the tractors and all of that.
Exactly, even the tractors now from Sunpure, for example, they are now having automated tractors, the AGV, and they even we're thinking to use this technology at some point of time. I believe if even it's reliable than the raw cleaners, and generally speaking, yeah. But we will see by means of testing and analytical results what is the difference. But it is still very expensive compared to the ARCS. Okay, coming to the second question that is regarding the whether it is worthy the energy of the robot and to use it compared to what is conventional or manual cleaning is used. And the question and the answer to this question, depends on what is it at what stage you are considering the robot. Is it a design? It's in the design stage, or you are retrofitting your plant as part of your O&M strategy to improve the plant itself? And to this point, of course, if you are retrofitting, you will face a lot of issues that maybe makes the retrofit a little bit difficult, and you will not harvest all the positive outcomes that you are seeing in an automatic cleaning robot that is considered during the plant design, not retrofitted. But surely it depends on your robot OEMs who maybe have the R&D team, okay, that can do the retrofit works for you in a very safe manner that will guarantee you the availability of the robot and the efficiency of the robot for your retrofitted plant. So absolutely, it is using the robot, but it depends in both areas. This is my personal professional opinion, but it depends who are the robot manufacturer, who are you using with in order to retrofit your plant. But if in the design, definitely go for the robot. And don't use, and there is no justification about the energy, especially that depends on the scale of the plant. But if the stand is smaller, definitely the energy price will be higher. And I'm talking about the utility here for the similar, contrary to the commercial and industrial, where maybe the robot use is difficult. So you need to use manual cleaners that is easier to move from one plant to another, whereby you need to clean once or twice every month. And again, it is very open-ended question and debate all around the day.
Thank you for answering this, Ahmed. Anything to add from your side, Alex, for this, or do you agree with Ahmed on the answer? Yeah, you are on mute. We cannot hear you. We cannot hear you, Alex.
Yeah, I agree. But regarding the price of the AGV robot, I guarantee it will go down.
Oh,
Okay.
what? Give me a guarantee now.
You make them happy.
But it's very funny in front of all of you.
On this positive note, I think we have reached the mark of the 1 hour and a half. I really think that we could have gone for another hour of this discussion now, but I really want to also save everyone's time. I know that you have meetings planned after this. So I wish to thank everyone, the hundreds of people that have attended this session from different countries all around the world. Thank you very much for your contribution. Thank you for the questions. I see plenty of questions. I've seen comments like from Mr. Alan Fenelon from Australia. So that provided some good insights that I will share with Ahmed afterwards. He directed that to you. And I thank everyone for their questions. I wish to also thank my esteemed panel in here, Alex, Asil, Ahmed, Koshagr, Amy, and our keynote speakers, Dr. David and York, for all of your input. Has been very helpful. And I think I knew that this would be a great discussion, but since I think we covered only 30% of what we could cover within this hour, 1 hour and a half, I believe we need to have a round 2 and discuss that into more details and have a deep dive, especially for the technical matters. Thank you very much. I enjoyed listening to you, learning from you, our dear experts, and I hope that this was a good session for everyone, where everyone learned something new and useful today. I wish you all a good day. We'll be in touch by email. The recording will be sent to everyone, and if you want to connect with the speakers, then please send us an email, info@solaralic.com, and we'll make sure to connect you with the speakers afterwards. Thank you very much and have a good day.
Okay, thank you. Bye.
Thank you
Thank
very
you.
much.